Why does salt make ice melt faster if the salt is not heating the ice? The key is that salt changes the temperature at which water can freeze. A block of ice may look completely solid, but at its surface, water molecules are constantly moving. Near the melting point, some molecules leave the solid ice, while others join it again. Under normal conditions, freezing and melting can balance each other. Now add salt. Salt cannot simply burn through ice. It first has to dissolve in liquid water and form salty water, called brine. On real ice, there is usually enough surface moisture or liquid-like water for that process to begin. Once the salt dissolves, it separates into sodium and chloride ions. These dissolved particles make it harder for water molecules to organize themselves into the regular crystal structure of ice. The result is called freezing point depression. Salty water must become colder than pure water before it freezes. That changes the balance at the ice surface. Imagine the temperature is just below 0 degrees Celsius. Pure water would normally prefer to be frozen there. But after enough salt dissolves, the new salty solution may have a freezing point below the actual temperature. At that moment, the liquid state is more stable than it was before, so some of the surrounding ice melts into the brine. As more ice melts, it adds fresh water and dilutes the salt. The process continues until the concentration and temperature reach a new balance. This is why road salt can clear an icy surface without acting like a heater. It changes the freezing conditions instead of supplying heat. The parking space picture can still help, as long as we use it carefully. Water molecules need to line up in an orderly crystal to freeze. Dissolved salt ions get mixed among them and make that orderly arrangement less favorable. They are not literally blocking individual molecules like a wall. They are changing the conditions under which the ice crystal can grow. But salt has a limit. As the temperature falls, ordinary sodium chloride becomes slower and less practical as a road de-icer. Around 15 degrees Fahrenheit, or about -9 degrees Celsius, its performance drops sharply in typical road conditions. It is not suddenly chemically useless at exactly that temperature, but melting becomes much slower. The sodium chloride and water system can remain liquid at still lower temperatures if the brine is concentrated enough. So salt makes ice melt faster for one simple reason. Once it dissolves, it lowers water's freezing point. The ice is no longer in balance with the salty water around it, so more of the solid ice melts.